purpose of this meeting is quite simple. It's for us to be together and learn from each other and teach each other how to make GIS free, among other things, and grow and get connected. A lot has been said already about who you are. You come from virtually every segment in India, almost every kind of business or government sector, every kind of academic sector. You're what I would call a multidisciplinary, multi-organization community. And while a small sample of Indian culture and population, you represent a very massive force. At the beginning of this meeting, I always like for you to get to know each other and start conversations. Like, you know, Raji, this new idea that you introduced to me has got me thinking. I'm going to use that idea throughout my presentation, if that's okay. That's a conversation. But for us to really learn from each other, we've got to get to know each other better. I mean, is there anybody in this room that knows everybody else in the room? I guess not. Okay, so stand up for me, turn around, introduce yourself to one new person. Let's start the conversation. Can you do that for me now? Stand up, introduce yourself to somebody new. Friends here, I'm anxious to get, you see how rich that is? I mean, the actual experience in this audience represents the fundamental knowledge about GIS in India. I mean, you guys are learning on the job, teaching each other, and it's very important that we connect and be a community here. 20 years ago when we first had this meeting, you say there was 100 people. I think there was only a few dozen, actually. And they sort of modestly showed their work, they brought their maps, and the world changed. So this community is alive and full of, I think, full of energy, and you'll see this over the next couple of days. Your work is really important. As modest as you might think it is, it's fundamental to the future, I think, of India. It's very nice that Esri India put this globe up here. I kept looking at it. It's just inspirational to me that the future of our world is going to be guided and directed with strong geographic information. I just know that. My background is as a landscape architect. I was taught how to do landscape planning. And to hear you, Raji, talk about the idea that geography matters, someone of your stature and background with IT, a landscape architect could have said that. But we're getting it pervasively understood, that we're connected to this entire ecosystem that we call Earth. I'd like to start this meeting by simply sharing some of your work and some of the work of your colleagues from around the world to get our minds going, and maps certainly do that. Some of you are working on environmental monitoring and environmental assessment, whether it's looking at potential sea level rise or carbon sequestration or simple things like noise modeling. These examples show the application of GIS in agriculture, micro-agriculture like in New Zealand, precision farming, but also looking over vast areas, agricultural monitoring, agricultural forecasting. Your work in energy is spectacular, not only looking at traditional forms of extraction, like carbon extraction and use, but shifting gradually to the use of renewable energy, picking the right locations for solar and wind. And in land information, parcels, land ownership, it's interesting to me to watch over the years what's occurring. In the beginning, it was simply making the maps, keeping the record. Now we're seeing exploitation of that, for example, through property reappraisal or assessment. This example that Raji shared about tripling the revenue from the tax base is a good example. Parcels are the foundation for the civil society, not only ownership, but also foundation for government and its revenues. This is progressing in India, both conceptually and also technically. Your work in urban and regional planning is attempting to create more livable cities, smarter cities, cities that are better designed, redeveloping cities, making cities more livable by walkability, etc., etc. And in the world of transportation, from the President to the Ministry of Transportation down, there are many, many examples of highway information systems, rail asset management, traffic modeling, etc., etc. Beautiful pieces of work that are just beginning. In the utility space, organizations like Reliance are not only managing the network, but then exploiting the network through various forms of analysis, national power restructuring, normalization, renewable energy integration into the grid. These are powerful things, from smart meters to smart utilities. And geography is moving into the micro areas, buildings. Even my old campus, Harvard University, is now using GIS to optimize room arrangement and scheduling. But we see it with smart cities visualized, interacting, planning, evaluating, understanding. In the private sector, equally, GIS is growing rapidly. We see it with organizations like Starbucks wanting to locate at the right location, insurance companies wanting to understand risk, the issues of flooding ultimately will be solved by changing the insurance policies. People won't be able to afford to live in urbanized areas. Well, maybe that's a bit of an exaggeration. But the private sector working with the public sector in using our common language of geography is making better decisions. One might say they're getting the geographic advantage through better site location and understanding risks. In the health dimension, GIS is coming along quite nicely. I saw this 20 years ago here with malaria. People were immediately able to see patterns and relationships. But today, there's only one case of Ebola left in West Africa. The WHO organization credits GIS as a strategic technology to put Ebola in the box and stop it. This is really interesting to me. But whether it's from malnutrition patterns to access to hospitals, GIS professionals work, people exactly like yourselves, are making the world a healthier place and a safer place. These maps show patterns of crime or where there's bad guys, and also how people can be safely captured and managed. The huge migrations that are occurring in Europe are represented by this slide in the middle. Migrants every day leave North Africa and try to get across the Mediterranean Sea, and many of them die. But this system is meant as a security net to help them along. Optimization of fire stations, optimization of public facilities. This is amazing, actually, what you and your colleagues are doing everywhere. Preparing for, responding to disasters like what's going now on in the south with floods, whether it's earthquakes or hurricanes. We'll see a lot of this today in the various demonstrations. And then simply making beautiful maps. I mean, some of you are excellent cartographers. These maps in the upper right show traditional maps like the topographic maps from the Survey of India, or aeronautical charts or nautical charts, and military secure cartography. And then fun ones like the little app up in the upper left showing cherry blossom schedules. So in Japan, some of you might know, it starts in the south and gradually, like a wave, cherry blossoms bloom north. So tourists love this. And then for some of you, beer hall accessibility might be a great map. It's supposed to be a joke, but you guys didn't get it. Isn't it funny or not? Maybe it's not funny. Don't you like beer? Okay, here we go. Too early in the day, exactly right. We are moving from traditional hard copy maps and web maps to a new medium. And we see this with hundreds of new maps published every day called story maps, and we'll see some of those shown here. People in India are now telling stories about circumstance, national park stories, Save the Tiger stories, the World Cricket match. What is cricket? I thought it was a little animal. No, it's something that you play here in India, I think. Well, anyway, beautiful, dynamic, fun storytelling. Geography is coming alive on the web. Also, there's major efforts around the world to provide more open data and citizen engagement. The next chapter in democracy will be increasingly built by you and your colleagues as you publish and share maps and web maps and data and engage different kinds of institutions. I'll talk more about that in a couple of minutes. All of these examples, those from India, those from around the world, are noteworthy. They give us little examples to showcase and talk about and talk with each other. Those organizations receiving the SAG Award this afternoon, I'm most excited about going to that session because, of course, it's nice to get acknowledged this way, but more importantly, they represent, through their distinction, good footprints for the rest of us to copy. How did they do it? What did they do? In various presentations during the week, that's what I want you to be curious about, not just the beauty of the map or the system, but rip off good ideas. That's what this meeting is really all about. The vision of this conference is not simply to share this kind of work, portals, citizen connections, and things like that, but it's really about creating our future. As the icon suggests, you are a special group of people in the sense that you are practitioners. Some of you just learning GIS, others quite advanced, some of you in senior management, some of you nurturing others, some of you teaching. This is a very important responsibility. Our world, as we read in the newspaper every morning, is increasingly challenged. Some would argue we are overpopulated. We are definitely consuming too much nature. We are in an age of unsustainable progress, if you want to call it that. And we see it everywhere. It's not like when I was a kid, frankly. We had 1/3 the amount of people, and we lived in more sustainable environments. Yes, we weren't as technically advanced, but we have to figure this out. And it's going to take every bit of our human thinking and technology and our best science to be able to create the future effectively. I would assert to you, my colleagues and friends, that geographic science, the integration science of our world, is a powerful platform. It's the science of our world, and it provides the content. Some of you build that content for India, and the context for understanding everything and addressing those very same questions, those challenges that we're seeing in social institutions of all type all over the world. GIS provides more than simply a technology. Underneath it is a framework and a process. The framework and process involves collecting data, let's call it with a fancy word, observational science, then modeling and predicting from our data, and analyzing and interpreting through overlay and analytics, and then creating a kind of understanding. So one might say GIS is all about understanding our world. And that understanding is the foundation for designing and planning, sketching, designing and creating and evaluating, and then making decisions. In many of your institutions, this is the role you play. You support the decision makers. Not always. Some of you are just about measuring, others just about modeling. But many of you are moving into the space of supporting decision making and ultimately action. So this little cycle, I would call it a virtuous cycle, is measuring, evaluating, and acting. Measuring and acting. And whether you like it or not, this framework and process is underneath every piece of your work, whether you're just a little desktop user or you're building a massive system. And as this evolves, the next 20 years, when I hope to come back, I will see it as more essential infrastructure which guides all human action. That's a very big idea, that we are moving to creating a nervous system for our planet. And we as actors in that nervous system are supporting this virtual cycle of measuring to feedback and guiding the world. This is the big idea. And we're all playing in it, consciously or not. GIS is helping us, as a result, be smarter. Your president here understands this, the idea that we are improving how we manage things and how we decide about things. He gets it. He's a data guy. He's an information guy. And he and his ministers and you and this whole society is moving to the notion of real-time monitoring everything, measuring everything that changes, and analyzing it and evaluating it and optimizing and automating. This is the sort of context of GIS. It's the context of your work. Whether it's smarter cities or smarter nations or smarter utilities or smarter businesses, this is the foundational stuff of what it's all about. Geodesign, from my field, plays into this. Geodesign is a new idea, but an old idea. It basically takes geography and allows us to sketch and design and evaluate and collaborate and create new plans on a continuous basis. And GIS is the foundation that supports it. So I would assert to you on my visit here this time that we're entering a period of geo-enlightenment, where you are waking up the world to the context and the content of a changing and evolving world. And we have the opportunity, in spite of all the negative things going on, to collectively alter, in our small way, alter the course of the future. This is both a big idea and also innate in every human, that they want to be better. They want to create a better future. Don't you want to do that? Isn't that what life is about? Better kids, better houses, better prosperity, better society, better world, sustainable world. GIS professionals, and here I'm speaking to you personally, are empowering this enlightenment. You're empowering the very evolution of what we're up to here. You're learning and training, getting connected, creating interesting solutions. That's what you do. And showing what's possible to your boss or your friends or society, applying GIS everywhere. Now, GIS itself, my work and my colleagues' work, is evolving. And a whole new pattern, a whole new paradigm of GIS is starting to emerge, has emerged. This is being driven by two big forces. One of them is technology forces, faster machines, big data, devices, smartphones, the consumerization of IT. All of these technology forces are contributing to a new pattern we like to call web GIS, or I certainly do. At the same time, feeding into that new pattern is content of all sources. I mean, from many new sources, more remote sensing, more LiDAR, more measurements, more demographic data, and increasingly real-time information coming in from satellites and other sources. And we could only dream about the kind of data that we have today 20 years ago or 30 years ago. It wasn't here. And this new technology pattern is accessed through apps and applications, the app cloud or app web world, so that we don't have to build everything from scratch. We don't have to program everything. We don't have to, no, we can configure technology and make it come alive in very short amounts of time and connect it with everybody, not just a few. So I'm not, Raji is as pleased as I am as this room is full, that it grew an order of magnitude in our little time period. This time, I want it to grow many orders of magnitude. And that'll be founded based on your work. It isn't going to be somebody else outside of this room that's going to build that grows it out for connecting and integrating all of us. Now, WebGIS is a new kind of pattern, and I want to describe this both contextually and technically so you really get it. There are three patterns we might describe: the server pattern, the desktop pattern. How many of you are desktop users here? Most of you. There are, let's just say, roughly a 1.5 million desktop users around the planet. The second big pattern is server patterns. This is where you put data in, you serve it out for thin client or desktop applications. Let's call it client-server technology. How many of you have servers available to you in the room? Yeah, most of you. Those two patterns are what we might call systems of records. And in a system of record, we transactionally maintain the records. Facility records, cadastral records, building records, water records. They're systems that are transactionally updated every day, and other people can look at them, sometimes in a desktop or sometimes not. The new pattern, WebGIS pattern, is a little different. The WebGIS pattern is a system of systems. So you can notice my little arrows here that the desktops are connected to a WebGIS. They're not replaced by a WebGIS. The servers are integrated in a WebGIS. They're not replaced by a WebGIS. So it's a system of systems. It kind of overlays on top of all of our collective work and brings it together under a portal. I'll come back to what a portal really is. A portal erase from your mind all of the sort of open data portal kind of things. That's not this. This is a technology that allows us to federate distributed servers and services into a master GIS, like you would imagine a national GIS or a state GIS or an organization-wide GIS. And this system of engagement engages people. You have an identity in a system of record. I'm Jack. I have certain privileges, and I have security limits of what I can do in the system. I can access some data, I can't access others. So today, we're full of systems of identity. They are like Facebook and Twitter and, I'm Jack. And it gives me privileges. So with a system of engagement, as opposed to a system of record, I actually bring together our collective work at some level inside of an organization. This is very powerful, actually. So Richard's going to actually show a little bit of what a system of engagement's about. I'll jump ahead for a second while we're waiting for him to come up and simply give an example that the World Health Organization, look at this slide, the World Health Organization uses this to create a real-time a real-time system of engagement GIS. They have apps out in the field that are collecting things like diseases like polio immunization, malaria, etc. They're actually updating a big database in the cloud. Other people are viewing the data in real time, like this map of actually disease spread. So we're simultaneously measuring and viewing the data at the same time. Then, by the way, at the same time, somebody else is looking at the same data in a dashboard. See that app up there called a dashboard? It's viewing the same data at the same time. And then other people are doing spatial analytics of the same data while the data is being collected. They're all doing it at the same time. They're operating at the speed of light. They're not doing a linear sequential thing. So a WebGIS is bringing the whole organization together in a real-time, connected with identity system. There's a new pattern for us in GIS. So it's not just web maps. We're talking about a WebGIS. He's giving you a scenario of what this means. There are thousands of scenarios. I shared the scenario of what WHO is doing it in health. There are scenarios in police, fire. These are emergency scenarios. But how many of you in your organization have field workers? Sort of not requiring emergency disaster, but you want to connect them into a system of engagement and see their work and help their work dynamically. So this WebGIS pattern is going to empower people like you. It doesn't require that you change out the desktops or servers. It requires that you overlay this WebGIS portal and bring your existing knowledge together. It expands and extends what you have, and the pattern is services and apps. Apps are the magic here. They're the things that bring it together. Apps for knowledge workers, apps for field workers, apps for executives, apps that show casual people like citizens or your customers, getting them engaged. Apps that do crowdsourcing, so you can bring in geospatial crowdsourced information, build your knowledge from the crowd, and apps that allow open data sharing with other organizations. WebGIS, let's look at it at the technical level. It's a different architecture. It's not the server architecture. The last big jump occurred with server architecture, where the concept was you buy a big DBMS, an Oracle or something like that, you put all your spatial data in there, and that's the answer, because at the enterprise level, everybody normalizes all their data. But that was hard because everybody had to agree on one data model, you had to squeeze it all into one database, you had to have it scalable, etc. And there's nothing wrong with that, except that it doesn't actually scale out to manage the heterogeneous nature of your organizations. So in contrast, this all your data available for free or all of your data available to everyone. You organize it into groups and you manage it effectively. This, ladies and gentlemen, is a big step. In my lifetime, we went from mainframes to minis to workstations to PCs to server architecture, now here. And Raji, when I was saying this isn't going to be an order of magnitude growth, actually, all of those other transitions were about an order of magnitude growth on the planet. This is going to be orders and orders, because it's going to open up your world so that you can support lots and lots and lots and lots of applications and users. It's going to change our organizations. Classically, our organizations, and I don't care whether it's at the national level or the state level or the city level or your business level, they're typically stovepiped, right? We have specializations. In science, they're the ologies: geology, climatology, archaeology, A to Z, archaeology to zoology. We've organized science very nicely so we could go further within our domains, same in our organizations. This concept means that we don't just own our own data. We can bring the world back together again. We can integrate all the ologies. We can see the world as a whole, just like this beautiful map up here. Your mind does all the integration. Now, technically, we can do the integration. And organizationally, when we talk about these ideas of a national GIS or a state GIS, for the first time, for the first bloody time, we actually have a technology that can bring it all together. That's what excites me now. And make it available freely as services like telephone dial tone, creating geography pervasively. So it's not only something that will bring our own organizations together, it also provides the platform for making connections across and between organizations. We are doing this in a number of selected cities. This is Los Angeles, California. The mayor there, he's kind of like your prime minister in a way for his domain. He said, I want to open up all of the thousands and thousands and millions and hundreds of millions of dollars that we spend on geographic information in my city, and I want to make it available to everybody else. Another thing he said is, I want my government to be an open platform for everybody else, not just internally used. So first he realized right away what a WebGIS was. He said, this department can use that department's data. I already told that story, but this is his next idea. He said, I want my city to be able to provide map services and data services to other governments. I said, Mr. Mayor, that's really a good idea. Get rid of redundancy. And he said, but I also want it as a platform for business. If people do business in my city and I get taxes from them, I want to leverage government as a platform so that their businesses are more efficient. And I want it open for business for startups. I want my community to be I want my government to be a center for innovation. And I want to use my government investments to be able to promote innovation, free, and to schools, and to NGOs, and to citizens. This is a very powerful idea, ladies and gentlemen, and finally we have the technology to enable that. So LA will be a showcase. Right away, our colleagues over here in Singapore are starting to do this. Abu Dhabi, we want to be an open city. Geneva, it's just like the idea got out, and now we have the technology to actually do it. So awakening the world to the power of WebGIS now is technically possible. But in my view, that's about 4% or 5% of the thing. The technology, in many ways, is really not that important. Although it's very important, enabling it, the big work is going to be done exactly by you. Empowering people, sharing this vision, working collaboratively. It's very important that you guys are friends, right? Not competitors or, no, this is a social thing here. Creating a culture of collaboration and sharing and open data and strong people like I know so many of you are. Good. Well, I have one other area that I want to talk about, and that is our work. I talked a little bit about your work. I talked about the vision. I now want to go into why you thought I was going to talk about our work itself, which is the development of the enabling tools, and I want to just share with you some insights of where we are and where we're going. So fundamentally, Esri's platform is ArcGIS. You guys know this. If you don't know this, you're in the wrong room. That was supposed to be a joke too, but you guys are really, you don't get my jokes at all. ArcGIS is a web GIS by design. At the bottom level, it starts with services from a server or from online base maps like ArcGIS Online provides. In the middle, it's organized through something we call Portal. This is the main instrument of a web GIS. And the portal manages something called the GeoInformation Model. I'll come back to what that is. Some of you might be thinking, what's a GeoInformation Model? And then at the top, it's apps and applications. The portal, this blue thing, manages identity. It manages you, and it manages security, and it manages the organization of the content into groups, like our group, or the external group, or our little teams group. That's what these three layers do. And this entire architecture you can set up inside your organization, or this entire architecture is also represented in ArcGIS Online in the open cloud. Or you can mix and match. The GeoInformation Model is intriguing, and this is where I want you to pay a lot of attention. I told you that this is not putting it all into one database. It's a new thing. The GeoInformation Model is a kind of virtual concept. It abstracts data from many different sources. So it takes classic geodatabase data or shapefiles, and it abstracts it into a layer. A layer is not a physical thing, it's just a pointer back to the data. It takes imagery data and it abstracts it into a layer. It takes enterprise tabular data, like Richard showed, drag and dropping tables, into a layer. It brings in real-time data like real-time traffic or the weather, and it abstracts it into a layer. You guys know what layers are. They're not really content, they're just an abstraction. Under the portal, I can organize my layers with metadata, and in the portal, I can search my layers, and with my layers, I can render the layers, I can color them into something called web maps or in 3D web scenes. This is a key moment, ladies and gentlemen. I'm trying to define for you the heart and soul of this new WebGIS pattern. WebGIS, some of you thought, was just web mapping. This isn't web mapping. This is a WebGIS. It has analytics, it has data modeling, and it, of course, has apps. So how can we make really simple apps really quickly, like in minutes or hours? Some simple tools that you'll see later. But most importantly, we have a single integrated REST-based abstraction of data that brings all kinds of data together. And the data at the bottom here, it can live on this machine and that machine. Some can come from Australia, some can come from Rome, it doesn't really matter. It comes from any place on the web. I bring this data together into this abstracted set of layers, and now I can really have some fun. I can mash them up. I can do analytics of one against the other. I can visualize it. I can republish, all in this environment. So you guys get this concept? This is a really, 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 really important concept. It's not the database concept, although it builds on database theory. Okay, once we have that done, what are the other big research areas that are going on at Esri? We're working on content for ArcGIS Online. This is all freely available to you. There are now thousands of data sets that cover the whole planet: imagery, base maps, soils, geology, vegetation, Landsat content. There's also over 5 million data sets that have been shared by our users. So up there and online, as you're hunting for a little data, you can actually search and find and drag a map in and into your WebGIS and overlay it and do some analytics dynamically. So we spend a great amount of money on doing this. And by the way, a little note on ArcGIS Online, there are now about 2.5 million users, named users. These are identity-based users. They make about 200 million maps a day on this platform. They add about 15,000 new maps or data sets a day. I mean, this isn't Facebook, right? It's not Twitter. But watch out, because that thing is going up fast. So that ArcGIS Online content library, the largest digital library of geographic data in the world, is growing fast. But that entire architecture can also be implemented inside your organization. If you don't want to put it in a cloud environment, fine. It doesn't really matter. A second major area of development is in the data management field. Here we're making improvements to workflows that do updating, and we're adding a new utility data model. We're integrating GIS with some new database technologies like HANA from SAP, continuing our work with IBM in Netezza and DB2 and so on. A third big area of development is in smarter mapping and visualization, both in 2D and 3D. We're adding vector tiles to our system so that we improve the performance of display and ability to analyze data. Also, we've added a new app that'll come out next week. It's called ArcGIS Earth. We're doing this collaboratively with Google. As Google has backed away from the Google Earth enterprise technology, they asked us to provide a new generation of our tools that would fit that niche. This Google Earth-like clone, it's not Google Earth at all, not only has this powerful visualization, but it also can integrate and overlay all of the content of the GIS world. 3D is a major theme in our research labs, and we're adding more tools with every release. Fast, everywhere GIS, with full integration of the KML world of the consumer mapping and visualization. A fifth area of development is something we call geodesign. I mentioned geodesign earlier. Geodesign is a conceptual process where we take data, we do analytics, and we allow our users to sketch alternative scenarios for their city or their farm or their plan, and quickly look at evaluating the consequences of those alternatives, and then make a decision. So we have real tools called GeoPlanner in 2D and City Engine in 3D that support exactly that sort of thing. A sixth area, perhaps one of the most powerful areas, is continuing to advance the science of geography with spatial analytics. Here we're looking at overlays and statistical relationships and predictive analytics in time and space. One that I'll call your attention to is something called Bayesian regression, or exploratory Bayesian regression. It's that big yellow thing. This allows me to take one layer, let's call it landslides, and overlay it against all the other layers and develop a statistical relationship of prediction. So I can then map out where landslides might go as a function of history, or where new commercial stores would do best as a function of history, or any other spatial regression analysis. That's one little tool. We're also integrating ArcGIS with the open source platform of R, so that R users, like R, the word, letter, can access Esri's GIS data for use in R, and also Esri, the other R-O-U-R users, our ArcGIS users, can access the powerful engines of the open source platform of R. And then increasingly we're putting these analytic tools online with portal and servers, so that in the web GIS pattern we can do spatial analytics of distributed information. That's really neat. We have a large development team for imagery. Inside of every ArcGIS system is a complete image processing system. Some of you are aware of this and some of you are not. It's enhanced with our partners like Harris and other BAE and others, but inside of ArcGIS now are over 100 powerful image processing tools that allow me to do feature extraction, and next year, early next year, we'll integrate complete drone support. So I can buy a very cheap drone, let it fly, let it land, take the imagery from it, pour it into ArcGIS, and it will automatically create ortho photos. This is going to change things. Like I want to fly along an electrical line, or I want to fly into a dangerous area like the floods right now, I can bring that data in, provide it immediately in the exact same pattern that Richard talked about here. It takes about 30 minutes to fly, land, process, and create digital mosaic orthophotos in multispectral information. This will change things, ladies and gentlemen. We're moving to an age of real-time GIS. And speaking about real-time GIS, there's an extension in the server called the GeoEvent server that reads real-time information. Small versions or large versions, like 3,000, 4,000, 5,000 observations a second, and turns it into maps, layers actually, that can be integrated into the WebGIS environment. This is the Boston Marathon, where this year there was a flawless marathon. Last year, as you probably might have read, a number of people were killed by this horrible thing that's going on in our global society. Notice the dashboard. It's bringing up the real-time situation. Dashboard is just a little app that you configure. It's free, and as Richard showed, we can see real-time situation looking into the GeoEvent real-time information sensor feeds. We're moving to an age where there's more and more data. We have to manage very large volumes. So this summer, we're coming out with something called the Big Data Extension, or Geoanalytics Extension. This will handle hundreds of millions to billions to multiple billions of observation points. Some of you have this kind of big data. In these series of maps, it's simply all the pickups and drop-offs of taxi cabs in New York City. And the data has been reduced in about 2 minutes to that little red dot that says that's the most important place for a taxi cab driver to pick up or drop off people if they want good tips. It's kind of a joke, but it's not exactly a relevant application, but you can get the idea that I can use spatial analysis in a Hadoop environment to derive some meaning or insight out of very big data. We have yet to figure out all of the applications for how big data is going to change society, but this is going to be an enabling tool that helps us. Number 10, we spend a lot of time at Esri making our platform an open platform. Now, in this room, there's probably 25 different definitions of what an open platform is. So our approach on this is to support interoperability of our platform in heterogeneous and complex environments. And we do this with multiple pathways to support openness. One of those is to support open standards with strong support for OGC's standards or WWW standards. And this is a process, it's not an event. Each release, we make improvements in it as the standards evolve. It's a big job. We have a lot of people working on it. The second pathway is to support direct industry standards. This means that one COTS package can talk to another COTS package without system integration costs. So, for example, AutoCAD and ArcGIS now directly connect, so I can edit things in AutoCAD that affect the geodatabase, or Oracle or HANA, or these sorts of interoperability and open platform solutions. The third one is open software. By this we mean open interoperability APIs that allow developers to talk directly with the data that's in our systems. And also open libraries, open source libraries. A lot of ArcGIS is actually based on open source, and we make a lot of the app solution technology, I'll come back to this in a minute, available in GitHub as open source libraries, so that app builders, startups, can build these apps with open source environments and then share them on top of our platform. And this is becoming very, 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 very popular and important. And in this country, with some of the new thinking about open source, we've made strategic decisions to go more open source with our platform so that people can share apps and leverage the base foundation. Finally, we mean by here open meaning an extensible architecture. This isn't just thrown together code. No, it's well-designed, well-documented, extendable, so I can add and extend capabilities and technologies, and many of our partners, and we have thousands of them, know this. The evidence that this direction works is probably best shown in the thousands and thousands of systems that have been implemented in heterogeneous, complex environments around the world. Okay, I shared a little bit of the inside of what we're working on in the labs. I want to now finish with a little discussion about how we bring this research together in the form of real products that ship in volume that you guys use. I mentioned that ArcGIS is a web GIS pattern. It has many pieces. Desktop pattern that connects in, the server pattern that connects in, the online pattern that connects in, a whole new family of apps that connect in. It's one ecosystem system. In many ways, it's like Apple's system. Okay, I have an iPhone. Maybe I left it on my coat down here. My iPhone, I buy an iPhone. It connects in with the iCloud. I can get iMusic. I can, like that. It's one actual system. And you buy it in pieces, but it's all integrated and in our case, open and extendable. I want to go through the different pieces of it. One is the desktop, and in the desktop's case, we had a release earlier this year which introduced a second app or application. Most of you use ArcMap, but a new application exists called ArcGIS Pro. The second component of this ArcGIS system are the apps. And out of the box, ArcGIS now travels with a whole family of apps. Field apps, office apps, and public-facing apps. The field apps are things like Survey 123, Field Collector apps, Workforce apps, which are work management in the field, and then Navigator apps. These all operate in a connected and also disconnected environment. They can feed field office apps like Dashboard. We've seen a couple of examples of that today. Or ArcGIS Earth, the new 3D Google viewer, or ArcGIS for AutoCAD. And then a whole new class of apps like story maps for connecting to tell stories to the public, or crowdsourcing apps, or taking photos and having them geo-referenced and put back into the enterprise database. These are basically out-of-the-box apps that you can easily configure. They just come with every server or with ArcGIS Online subscriptions. But many of you have your own app challenges. And there are three environments I want to talk about here. The web app template suite that you can easily configure for your web maps. So remember, the heart of a web GIS is layers with web maps or web scenes. Remember that? And apps are the things that exploit those web maps. Simple, really. It's a new vocabulary. We've got maps and we've got apps. So we have configurable templates of apps. We have apps out of the box. But we also have two kinds of web app or app builders. The first one is the web app builder for using HTML5 or JavaScript. I can build an app and let it go very quickly. It has little widgets. I can configure these and make an app, and boom, I got something going right away. This is a big jump over the Flex kind of technology that was so popular a few years ago. The last one I'll mention is something called App Studio. This is actually for building native apps, where they run and take advantage of the native characteristics of the device, like an iPhone or an Android device or a Windows environment. So it works just like the web app builder. I can design an app, compile it for one, but it automatically can be recompiled and used in another operating system. So I build it for the Apple environment. It runs in Windows. It runs in Android. The author of this App Studio environment, it's actually Satya right here. Stand up, Satya. He's my hero, and he's going to talk about this afternoon in one of the presentations. If you haven't guessed it yet, one of our big strategies at ESRI is to open up the hood of ArcGIS engine technology and make it available for developers with app tools, with templates, and also open APIs and runtimes to take advantage of your interest in developing your own apps, and also to take advantage of the huge creative resources around the world, particularly here in India, to build whole new solution suites. The third big technology is the server. And we've talked about desktop, we've talked about apps. Earlier this year, last year I guess it was, we released Portal with the server technology. By now, I hope that you realize that Portal is a separate technology from the server. It's not just a user interface of the server. It's a fantastic piece of technology that makes web GIS come alive in organizations. It does the content management, it does the federation, it does identity management, all those things I've been talking about. And what's coming here is the integration into the server environment of this big data capability and the new utility network and GeoJSON and lots of other things. The fourth building block of the ArcGIS system can run again entirely alone, but also is integrated, is ArcGIS Online. This is a complete SaaS solution of ArcGIS, so people can subscribe to it. It has smart mapping, it has analytics in it, it lives in the cloud. It can be integrated into your desktops or integrated in and used with all of its content with your overall system. And we're making major headway in this environment as well. On top of all of the ArcGIS platform, we developed something called solution templates. How many of you here know about solution templates? 1, 2, 3, 4, 5, 6, 7, 8. Wake up. These pieces of software are free. There's a huge development force that's building them, some here in India with our colleagues from Cybertech. These are a free, open-sourced family of solutions, and there are hundreds of them. You can go to this website and download a whole set of workflows and graphic templates and applications, basically, that come alive in different domains, utilities and local government and national government, and security and military, etc. So take a look at this. Because it's free, it's open source, you have the rights to be able to take it and build an app out of it, configure it, share it back. This is a major piece of our going forward strategy for our platform, is open sourcing solutions. Right now these are largely from Esri and our partners, but in the future we're going to make this an open platform using GitHub to share all sorts of open sourced applications that live on the platform. There are also a series of solution products. Some of them are used here, like in the Survey of India, for map production, for decision support, for doing geoplanning, and other specialized tools for transportation. I've talked a lot about this technology, our work. I suspect that you wanted me to. I want to give you a sense of where we're going next. Earlier this year, we released 10.3 and Pro, its first version. In the summer, it was updated with 10.3.1 and Pro.1. In January, this is only 2 months from now, we will release 10.4, another big step in the evolution of the platform, and also Pro 2.1. And then, between then and the summertime, there's just a huge amount of technology that's going to be released, finalizing in the summer release of 10.4.1. To handle the big data, to handle advanced navigation, to handle more real-time, to handle spatial BI, to handle distributed GIS, lots of enhancements. So stay tuned. I've talked a lot about the technology. Ajendra talked a bit about our philosophy. We are now 46 years old. We continue to be dedicated to our users. We have no outside stockholders. It's owned by me, but also my partners in each country. Esri India is owned by, you met some of them already, Indians. And Esri Australia is owned by Australians, and Esri China is owned by Chinese, and Esri You get the idea. There are actually over 100 of these locally owned companies who build code, who work with our customers as a federation, a federated business around the world of ideas. We also support another kind of ecosystem, which is a NGO ecosystem. We provide free software to NGOs around the world. Some of them are quite big, quite advanced. Some of them are quite small. And they work on local problems or conservation problems or humanitarian issues. I'm very proud of this because they enrich the community that you and I live in. Their contributions, their use of your data is very rich and makes a difference in the world. In the education space, we also have thousands of educational partners. Some of them just teach the basics of GIS, and some of them are very rich in their educational capabilities. We need more educators in India that teach the knowledge that you hold in this room. So I want to work with you to grow a strong educational foundation more than exists now in the world and also particularly in India. And my colleagues here at Esri India are doing their best, but they need your help and your coaching. Not only with the technology, but the idea that you could mentor kids in school or students or educators about the knowledge that only you guys really know, which is the application of GIS. This is one of our weak points in India, is the next generation. We have to think about how do we build the humanware, not the software and the hardware and like that. We need to build a human foundation that'll take this thing forward and realize the visions of this administration and others. Well, I've covered a lot of ground. I appreciate you spending time with me. I think of you as my old friends and colleagues. Some of you are my old friends and colleagues. I really believe in our work, our collective work, particularly this idea that GIS and geography can create a better world. So thank you. Thank you very much.